Right now, 93 million miles away, the sun is unleashing a storm that never stops. A solar wind of charged particles that hurtles throughout space at close to 1 million miles per hour. This invisible river of fire doesn't just drift past us. It interacts with Earth. It creates our northern lights, scrambles satellites, and has the strength to shut down entire power grids on Earth. NASA pointed its instruments at the sun's storm, and space answered back. The sun has a voice, and it's terrifying. But the sun isn't the only one with a voice. Across the solar system, planets and moons sing in their own strange frequencies. Space, it turns out, isn't silent at all. By the end of this episode of Natural Forces, you'll have heard the raw, alien voices of the sun, the planets, and the void beyond. And once you hear them, you'll never think of space as silent again. Before we hit play on these recordings, there's a question we need to answer. How can you hear anything in space? After all, space is a vacuum. Traditional sound waves, the kind that rattle the air and reach our ears, simply can't travel there. Instead of sound waves, the sun sends out electromagnetic waves and plasma vibrations, ripples of charged particles moving through magnetic fields. And here's what's so fascinating. Many of these vibrations naturally fall within the range of human hearing. The only reason we don't hear them out there is that the pressure in space is too low for our ears to pick them up. So how are we able to hear them now? Well, NASA's spacecraft carries instruments that can detect these ghostly oscillations and translate them directly into audio. Imagine electrons spiraling around magnetic fields, creating invisible pressure waves. When those signals are converted, what we hear is a raw, haunting chorus of particles and fields in constant collision.
6, 5, 4, 3, 2, 1, 0. Liftoff of the mighty Delta IV Heavy rocket with NASA's...
Our first stop takes us to the edge of the impossible, where humanity reached out and brushed the surface of a star. On December 24, 2024, NASA's Parker Solar Probe dove into the sun's outer atmosphere, skimming just 3.8 million miles above the surface. To get there, it had to move at a speed no human creation had ever achieved before. 430,000 miles per hour, faster than a bullet, faster than anything we've ever built. But speed wasn't the most shocking part, it was what Parker heard. As the probe ripped through the sun's shimmering corona, its instruments picked up something eerie, a sharp, unearthly screech, rising and falling like a scream trapped in static. Listeners later described it as chilling, like the wail of a ghost, or even what hell itself might sound like. What Parker was recording wasn't sound in the way we know it. You see, space is silent. Instead, it was the voice of plasma itself. Electrically charged particles dancing along magnetic fields, erupting as Langmuir and Whistler waves. When translated into audio, they became a haunting, high-pitched keening. It converts to the sun singing in a register no human ear was ever meant to hear. Now, beneath the sun's blazing surface lies a hidden rhythm, a low, pulsing hum. And this is where our second recording comes in. For over 20 years, NASA and ESA's Solar and Heliospheric Observatory has been listening to the sun's heartbeat. And yes, our star really does have one. The low, pulsing hum is the sound of acoustic waves ricocheting inside a sphere of plasma 865,000 miles wide. But did you know that the steady rhythm hides nothing but chaos? Millions of plasma jets called spicules erupt across the surface every moment, each one as wide as a city and moving at up to 250,000 miles per hour. And stranger still, scientists have found waves moving against the sun's own spin. Retrograde vortex waves are racing 3 times faster than theory predicted. It's like a guitar string vibrating in the wrong direction, breaking the rules of the song itself. When sped up 100,000 times to make it audible, what you're really hearing is more than just vibrations. It's convection currents, nuclear fire, and rogue plasma waves all colliding into a drone that sounds almost alive. Turns out the sun is quite literally an instrument of physics, and we're just beginning to hear the full score. Our third recording drags us away from the sun's warmth and straight into the frozen vastness of the outer solar system, into the jaws of Jupiter. Jupiter is no ordinary planet. In fact, it is a monster so huge you could fit over 1,300 Earths inside it. And it guards itself with the most powerful magnetic field of any planet, stretching so far into space that it nearly brushes Saturn's orbit. If human eyes could see Jupiter's magnetosphere, it would dwarf everything in the night sky, ballooning larger than the moon itself. When Voyager 1 flew past in 1979, it crossed that invisible boundary and recorded something no one had ever heard before: plasma waves, solar wind particles slamming into Jupiter's magnetic shield. But Jupiter isn't just defended by its invisible field. It's also home to storms on a scale we can hardly imagine. Lightning buried in its clouds crackles with a force 10 times stronger than Earth's most violent bolts. On Earth, lightning gives us thunder. On Jupiter, it echoes like something mechanical. It's alien, like the planet itself is a giant machine grinding to life. Now, by this point, you might expect the weirdest, most alien sounds to come from distant stars or massive storm planets. But Earth has its own haunted soundtrack. Our planet crackles, hums, and even sings in radio waves. Lightning storms, shifting magnetic fields, and the dancing auroras at the poles all contribute to a hidden chorus. Scientists call these signals things like spherics, tweaks, whistlers. And then there's the piece that stops people cold, the dawn chorus. Listeners often swear they hear birds, frogs, even whales in these sounds. Take the whistler, for example. A lightning bolt fires, the signal pushes up through the ionosphere, then it rides along Earth's magnetic field to the opposite hemisphere. When played back as audio, it descends like a sigh, as if the sky itself were exhaling. Frequencies usually fall between 1 to 5 kilohertz for these whistlers. And the dawn chorus? It doesn't just sound like nature waking up. It is something quite extraordinary. Waves of charged particles bouncing along magnetic field lines create a chorus that often peaks just at sunrise. It's Earth's magnetic field singing, not birds. Fun fact, some of these whistler mode waves occur in frequency ranges that are a fraction of the electron cyclotron frequency. Twists in physics that mean they travel through magnetized plasma in weird, dispersive ways. Because of this, high frequencies arrive sooner than low frequencies, giving that sliding, descending pitch in the whistler. At the very edge of everything we know, where the sun's influence fades into the void, our fifth recording comes alive. To capture it, we have to follow Voyager 1, an unlikely pioneer that carried humanity's ears to the very edge of the solar system. Voyager 1 was never built to last this long. Launched in 1977 to take a quick tour of Jupiter and Saturn, it was supposed to shut down decades ago. Instead, in 2012, the little spacecraft did something almost unthinkable. It drifted 14 billion miles from Earth and slipped out of the sun's protective bubble. You'd expect silence out there in the space between the stars. But what Voyager picked up was a sound scientists had been waiting for, the faint whistle of plasma vibrating in interstellar gas. What's interesting is that the tone didn't match what it had heard inside the solar system. Within the heliosphere, those plasma waves rumbled at a modest 300 hertz. Beyond the boundary, the pitch shot up to between 2,000 and 3,000 hertz, a clear sign Voyager had stepped into denser material, a galactic cloud pressing against the sun's frontier. It wasn't a one-time fluke either. Every so often, a massive solar eruption, aka a coronal mass ejection, blasting billions of tons of gas into space, crashes into this frontier more than a year later. Each impact makes the plasma sing again, like a struck tuning fork, and Voyager listens from the other side. To the scientists, it was conclusive proof humanity now had an instrument floating in interstellar space. To everyone else, it was something more haunting. But this wasn't just static. It was the sound of our solar system's edge, the place where home ends and the galaxy begins. Our last stop takes us to Saturn, a world of storms wrapped in rings of ice. For 13 years, NASA's Cassini spacecraft orbited this giant, peering into its atmosphere and diving between its rings. And what it heard there was electric. Cassini picked up the crackle of lightning storms roaring across Saturn's cloud tops. On Earth, you might recognize that sound if you've ever tuned an old AM radio during a thunderstorm. Bursts of static, pops, and crackles from lightning's radio waves. But Saturn's lightning, it's stranger. Filtered through an atmosphere of hydrogen and helium and warped by a magnetic field far stronger than ours, the signals become something eerily alien. Familiar static reshaped into tones that don't quite belong to Earth. And then there were the dust strikes. Microscopic grains of ring material slammed into Cassini at tens of thousands of miles per hour. Each impact registered as a sharp ping. String them together and it didn't sound like space at all. It sounded like a hailstorm hammering metal. That's what makes Saturn's soundscape so unsettling. Earth's electromagnetic noises have an organic, almost natural flow, bird-like chirps, whale song tones. Saturn's, by contrast, feel mechanical, rhythmic, precise, as if the planet were less a swirling ball of gas and more some vast machine still grinding away in the dark. The sounds Parker's Solar Probe brought back aren't just eerie noise. They're the sun spilling its secrets. Every spike, every hiss is a clue about why the corona, the sun's wispy outer atmosphere, burns at over 1 million degrees, hundreds of times hotter than the surface itself. It's like standing next to a campfire and realizing the air around it is hotter than the flames. One of the biggest revelations, those sudden magnetic switchbacks, sharp S-shaped bends in the solar wind, are far more common than anyone imagined. At first, scientists thought they came from deep inside the sun, like cracks in the surface bubbling outward. But Parker found many of them forming farther away, out in the wind itself, bending space like invisible whiplashes. They might be one of the missing links in how the solar wind gets its incredible speed. And if we can understand these sudden reversals, it could help us better predict the storms that reach Earth and disrupt satellites and communications. And then there are the waves themselves, called the kinetic Alfvén waves. Imagine ocean swells, but made of charged particles and magnetic fields rolling across space. As they move, they bleed energy into the plasma, heating it up and accelerating particles along for the ride. Without this constant invisible stirring, the corona couldn't stay blisteringly hot, and the solar wind, the very stream of particles that paints our skies with auroras, wouldn't exist. So when you hear Parker's recordings, you're essentially listening to the machinery that powers space weather, the same physics that can knock out satellites, scramble GPS, and ripple through power grids on Earth. For 60 years, scientists have been chasing this mystery. Now, piece by piece, the sun is finally talking back. And as we learn to hear our star, we're gaining the tools to listen to others. Other stars, other systems, unlocking the rhythms and tempests of suns light years away. In a sense, Parker has given us a new sense, letting humanity point a microphone at the universe itself. By the time we've listened to these 6 recordings, one thing becomes clear: space has a soundtrack, and we've only just started tuning in. From the sun's searing plasma storms to the way charged particles ripple around Jupiter and Saturn, to the surprising whispers of our own planet's magnetic field, the universe is alive with motion, and it's speaking. Perhaps at one point, these sounds were mere curiosities, but now we're seeing them as clues for potentially unlocking a million things about the universe. They reveal how solar winds race through the solar system, how magnetic fields twist and stretch, and how our planet interacts with the rest of the cosmos. Every pulse, crackle, and surge tells a story of energy, force, and movement on a scale that's hard to imagine and impossible to ignore. And this is just the beginning. As we send probes further, and as our instruments grow sharper, we'll uncover sounds stranger, louder, and more mesmerizing than anything we've experienced. The universe has been performing all along. We're just starting to listen. Thanks for watching today's episode of Natural Forces. We hope you learned something new. Stay tuned for more episodes about the natural forces that shape our world and universe.